table, and let us restart right here. Okay. Okay. So the problem that we are going to solve, or the next one is 2x squared plus 10x plus x plus 5. So here, if we see step number one, is there any common factor across all the terms which I can eliminate? Obviously, no, there is no common factor across all the four terms. But if you see, I have got four terms, and obviously I can use it, the first technique that we studied yesterday, grouping by pairs. Okay, and let me group it by pairs as I have indicated right here. So I can say it as 2x squared plus 10x plus x plus 5, obviously by using the associative property of addition. So that is nothing but between these two terms, what can be taken as a common factor? Obviously, the highest common factor that I can take here is 2x. So if I take 2x as the common factor between the first two terms, what I would get is, so 2x squared by 2x is nothing but x, and 10x by 2x is nothing but plus 5, right? And the second term, I need not really change anything. So let me retain it as x plus 5. And if you ask me why, because here you have the answer. So the reason why we actually take the common factor is to find out any common factor across the terms. So I have already got x plus 5 as the common factor. So I need not change anything in the second term. Now, between this term and this term, obviously the common factor is x plus 5. So if I take x plus 5 as the common factor, so the remainder from the first term is nothing but 2x, and here it's nothing but x plus 5 by x plus 5 is plus 1. So this is your answer. So x plus 5 into 2x plus 5, 2x plus 1, sorry. So both of them are nothing but factors, and the highest power of variable in each of these factors is 1. So obviously this is fully factorized form of the given problem, right? So which means uh, we are pretty good at this. So now let us go to the next practice problem. That is again a pretty easy one. So 4c squared minus 1. 4c squared minus 1. So again, step number one, is there any common factor across these two? The answer is no. But I have said just before, while we are practicing the other problem, that if the term associated with, or the fact of, or the term associated with, your variable square is a complete square, and the other one is number, very easily we can express it as difference of square. So 4c square can be rewritten as 2c whole square minus 1 square. So that is nothing but 2c plus 1 into 2c minus 1, and you can write, because we know the identity, a square minus b square equals to a plus b into a minus b. Again, I'm insisting that do not forget to write this identity. It's a very good practice. And obviously, if I'm the examiner, then I would at least deduct, if suppose this is a 2-mark problem, I'll deduct at least half mark if somebody is not writing the identity. Okay, now let's go to the next practice problem, and I hope you have already noted this down, right? Good. So let us move on to the next practice problem, which is 9x squared plus 3x minus 12. Okay, 9x squared plus 3x minus 12. So again, can I take any common factor all these terms? Answer is yes. So that is a common factor 3, which I can eliminate from all of these. So let me rewrite this as 3 is the common factor. So now what is the new form of the first term? 9x squared by 3 is nothing but 3x squared, right? So, and I hope we understand that when we are taking a common factor, that means we are dividing this, from all the other terms, right? 3x by 3 is nothing but x, and 12 by 3 is nothing but 4. There's a minus sign here, so it will be minus 4. So if I take 3 as a common factor, now this gets reduced to 3x squared plus x minus 12, right? So now this is what I'm getting. Now here, if I want this part, I have already got a pure number. Now I need to factorize only this part. So, and if you see here, this looks like a sum and product type. Now, my this term is minus 4, and here we have got, plus 3x squared. So, okay, so I can, okay, so in sum and product type, we have not seen if it is ax squared, how to do. So I'll leave that for now. So I'll just follow what we have studied. Okay. So here, so let us see. This is nothing but p. So we'll say this is nothing but 3 into p. Okay. Say this is equation 1, where where we assume that p equals to how much? P equals to 3x squared plus x minus 4. Okay. So now what we will do? We will factorize this and we'll put the value of p right here. Okay. So if the expression is 3x squared plus x minus 4, right? So I can take it as a regular quadratic trinomial, and I can use my middle term splitting technique to factorize this. So if I'm using the middle term splitting technique, so here my a will be how much? Coefficient of x squared, that is nothing but 3. My b will be nothing but coefficient of the middle term, that is 1. My c will be nothing but coefficient of the term without any variable, so that is minus 4. So a is 3, b is plus 1, c is minus 4. So if this is there, then obviously, okay, so here let me write it. This is nothing but 3 into p. I'll use it later, okay? So I need this really straight, so let's use it. Okay, so my a equals to 1, a equals to 3, b equals to 1, c equals to minus 4. So I can write m plus n equals to b. So that is nothing but m plus n equals to plus 1, right? And obviously mn equals to ac. So that is nothing but mn equals to a is 3, b is minus 4. So 3 into minus 4, or your mn equals to minus 12. Okay, m plus n is 1, mn equal to minus 12. So obviously m minus n will be nothing but root over of m plus n whole square, that is 1 square, minus 4 into mn, that is minus 12. So that is nothing but 1 plus 48 root over, so that is nothing but root over of 49, so that is nothing but 7. So m minus n is 7. Now we'll just use our solving multiple equations or simultaneous equations. So m plus n equals to 1, m minus n equals to 7. So that is nothing but, if we add both these equations, so plus n minus n will get eliminated, and your 2m comes out to be 1 plus 7 equals to 8, or m is nothing but 4. M equals to 4. Now we want to find out n. So let us subtract both the equations. So m plus n equals to 1 minus m minus n equals to 7. So if I'm doing a minus, the coefficient of this one will be minus, coefficient of this one will be plus, and here coefficient will be minus. So plus m minus m gets eliminated. So your 2n equals to 1 minus 7, that is nothing but minus 6. or n equals to minus 3, n equal to 4, and n equals to minus 3. Okay, so now let us rewrite that. Okay, now if we rewrite it, so what was our equation? M is equal to this, n equal to that much. Okay, so we had found this one to be 3 into 3x squared plus x minus 4, right? So yeah, so let's keep moving. Okay, so 4 and minus 3. So we know that our p, which is nothing but your 3x squared plus x minus 4, right? So this can be rewritten as 3x squared plus, we know that middle term is written as m plus n. So that is nothing but 4 plus minus 3x minus 4. Okay, so this is nothing but 3x squared plus 4 into x is 4x, minus 3 into x is nothing but minus 3x minus 4. So again, 4 terms, but if you see, if I bring these two together, I can take common term, and if I take these two together, I can get common factor. So I'll just rewrite this part as 3x squared minus 3x plus 4x minus 4, right? So now, if I take first two terms as the first pair, last two terms as the second pair, then I'll get here 3 goes common. Sorry, your 3x will go common factor, and the remainder here is x minus 3, right? X minus 3. Okay, and between no, hold on, 3x is the common, so it will be x minus 1, right? And between these two terms, if we take 4 as the common factor, what remains is x minus 1. Now x minus 1 is the common factor across both the terms, so if I take x minus 1 as a common factor, I get 3x plus 4, right? So now, if you see, p is expressed as x minus 1 into 3x plus 4. So this is one factor, this is another factor, and highest power of the variables are 1 in each of the factors. So this part is now fully factorized. So now all that I need to do, I need to put the value of p in this equation. So just write down that by putting the value of p in the equation, by substituting or putting whatever you want to write, the value of p in equation 1, we get 3 into x minus 1 into 3x plus 4, which is the fully factorized form of this problem, right? So this is how this can be solved. Okay, yes, and again, this is just one technique. You can use many other, right? So like you can even before taking 3 as a common factor, you can directly take, this much equals to A, this much equals to B, this much equals to C, and do that middle splitting right from step 1. That could be one way. Another way could be, after taking your common factors, right? So after taking your common factors, we got 3 into x squared plus, sorry, 3x squared plus x minus 4, right? So the product is 4 into 3 is 12, that is minus 12, and summation should be plus 1. So I can rewrite this is nothing but 3x squared as plus 4 plus minus 3, because the factors of 12 are one of the pair of factors is 4 and minus 3. So if I take 4 and minus 3, 4 plus minus 3 is plus x, and 4 and into minus 3 is minus 12. So I can express this as sum and product type also. 4, no, sorry, wait. Yeah, plus your minus 4. Okay, no, so it's not sum and product type, but still, if I want, I can just, split the middle term as 3x squared plus your 4x minus 3x minus 4. Now, if you see, you can just shuffle it, or you can put 3x here minus 3x plus 4x minus 4, and then you can just do the grouping by pair and solve it easily. So that's why we have been saying repeatedly that there are multiple ways of solving most of these problems. Okay, now let's go to the next one. Okay, so that is 12x squared minus 29x plus 15. 12x squared minus 29x plus 15, right? So here directly we understand that we have to use your middle-term splitting. So take this one equals to A, minus 29 is B, and 15 is C. So A is your 12, B is minus 29, and C is 15. So obviously now we need to split the middle term B into two terms M and N such that M plus N equals to B, or obviously M plus N is nothing but B is minus 29, and Mn equals to AC. Again, I am repeating, many students forget to multiply it as A into C. They just write C. So be careful on that. So Mn is nothing but 15 into 12, or 12 into 15 rather, and we are writing AC. 12 into 15, that is nothing but 180. Okay. So what will be the value of M minus N? So that is nothing but M plus N whole square. So minus 29 square, right? Minus 4 into 180, right? So let's find out what are the values. So 29 square. So what is the value of 29 square? Let's quickly find it out. So let me use my calculator to find out the value of square of 29, right? So just give me a moment. 29 into 29 equals to 841. So what I get here is 841 minus 4 into 180 is nothing but 720, right? So 841 minus 720, that is nothing but 121 root over, that is nothing but 11, right? So your M minus N equals to 11. Now this problem obviously becomes very, very easy. So M minus N is 11, M plus N is minus 29. So as I need really straight, let me remove some part of it, or erase some part of it. So I know my M plus N equals to minus 29, and M minus N came out to be 11. So if I add both these equations, so N and N will get eliminated, or 2M is nothing but minus 29 plus 11 is 18, or M equals to, sorry, minus 18, or M equals to minus 9, right? Minus 29 plus 11 is minus 18, and then obviously M equals to minus 9. Very good. Now, if I subtract one from the other, let's see what would I get. So m plus n equals to minus 29, m minus n equals to 11. If I subtract equation 2 from equation 1, this one will become minus, this one will become plus, this one will become minus. So obviously m and minus m will get cancelled out. So 2n is nothing but minus 29 minus 11. That is nothing but 29 plus 1 is 30 plus 10 is 40. So that is nothing but minus 40. Or n is nothing but minus 20. Okay. So if you see m is minus 9, n is minus 20. Now we'll just replace these values in the first expression. Okay. Okay, so now I can rewrite this equation as 12x squared minus 29x, I'll write as minus 20x minus 9x plus 15. Okay, so that is nothing but, let us now change it. Okay, so here what we are getting is 12x squared minus 20x plus 9x and plus 15. So we need to shuffle these to get the right set of pairs and do, your what you say, your grouping by two. So let us go ahead and do that. Okay. So between 15x and this, so if I take between 12x and 15. Okay. So let us check, right? Because we do not know which one to be taking. So 12 x squared, and let me take minus 9x here, and let me take your 20x to this side. So this is 15 minus 20x. Okay, so if I take these two as one pair and these two as the other pair, let's see what happens. Okay, so here the common factor would be 3x. So if I take 3x as the common factor, then what I'll get is 4x. No. Oh, yes, yes, yes. So if I'm taking 3x as the common factor, then I'm getting 4x here, and here I'm getting minus 3, right? So this is 12x squared by 3x is 4x, minus 9x by 3x is nothing but minus 3. Between these two, 15 and minus 20x, right? So if I take 5, or if I take rather minus 5 as the common term, then I'll get, this one is minus 20x, so this will be plus 4x, right? And this is plus 15, so this will be minus 3, right? So if you see, we have again got the common factor between the two terms. Now, I can take this 4x minus 3 as the common factor. So if I take 4x minus 3 as the common factor, what I get is, so from here, your 3x will remain, and from here I'll get minus 5, right? So I have factorized it as this much, your 4x minus 3 into 3x minus 5. So I got factor 1, I got factor 2, right? Because they are multiplications, okay? And then the highest power of x is 1 in each of these factors. So obviously this is the fully factorized form of the given expression, okay? You can type it down, and then I'll just go to the next practice problem, okay? Fair enough. So we are already done with this side. Now let us move to the last few problems. I understand this is a long class today, but that's fine. This was expected to be a long marathon class. Okay, had that. If we have not had that internet connectivity issue, then obviously I know that we would have finished everything in one shot. Okay. Anyways, x plus 2 whole square minus 4. Okay, so the reason why I had corrected this problem is Remember students, every time you may not get just square the direct of, so this first term can also be an expression itself. So if it's a square of an expression also, that is still fine. We can still use your a square minus b square identity, right? So here this is expressed as x plus 2 whole square minus square of 2. So this is one term. So I can say this is a square and this is b square. There's a negative sign. So I can say this is nothing but x plus 2, a plus b, right, into a minus b, that is x plus 2 minus 2, right? And if you want, and we should write the reason here that a square minus b square is nothing but a plus b into a minus b. Okay. Now we can further simplify it. So we can say that x plus 4 into x plus 2 minus 2 gets cancelled out. It is x. So I can say x into x plus 4 is the answer. So the fully factorized form of x plus 2 whole square minus 4 is x into x plus 4. So yes, now we have got two factors, this and this, right? And obviously the highest power of x is 1 in each of those factors. So obviously this is the fully factorized form. Now let's move on to the next practice problem, that is 25x squared minus 16. So again, this is one of the very simple ones, 25 x squared minus 16. So here it can be rewritten as 5x squared minus square of 4, right? So a squared minus b squared. If it is a squared minus b squared, then I can write is a, that is 5x here, plus b, that is 4 here, into 5x minus 4. This is the answer, right? And you can write the reason as a square minus b square is a plus b into a minus b. Okay, good. So let's move on to the next practice problem, that is xy plus 2x plus 2y plus 4, right? So here, if you see, again, I have got four terms. Let me logically take these two as, two pair of terms, right? So if I can rewrite this as xy plus 2x bracket plus the second pair is 2y plus 4. And if you can write it, because addition is associative by nature, right? So you can write that reasoning also there. So now between the first two terms, okay, I can take x as the common factor, and what will remain is from the first term I get y, from the second term I'm getting 2, y plus 2. Now similarly, between the third and fourth term, if I take 2 as the common factor, what I get is y plus 2. Now, y plus 2 is the common term or common factor across both the terms. So if I take y plus 2 as the common factor, what I'll get is this much by y plus 2 is nothing but x, plus this much by y plus 2 is nothing but 2. So your answer is y plus 2 into x plus 2 to this problem. So you may write it down, and I'll just use that time to drink a bit of water. Okay, so I hope you have written it down. So let's go to the next practice problem. Okay. So next one is minus 5x squared minus 10x. So don't get confused if you are getting negative coefficients for both the terms. That's perfectly fine. So we'll just use the first step, that is what is the common factor across both the terms. So the highest common factor across both the terms is minus 5x, right? So if I take minus 5x as the common factor, so from here I'll get only x, because minus 5x squared by minus 5x, because this is what we mean by taking the common factor, right? We divide the common factor across all the terms. So 5 cancels out, minus minus cancels out, x and 1x cancels out. So what remains is x. So that's why I'm writing x here, right? Minus. Here if we say minus 10x by minus 5x, minus minus cancels out, x cancels out, 5 2 is 10. So what remains is 2. So x minus 2. And this is your answer. Because obviously now something that was expressed as t1 plus t2 or term 1 plus term 2, you have expressed that as factor 1 into factor 2, right? Factor 1 into factor 2, and the highest power of x in each of these factor is 1. So this is your fully factorized form, right? So now let's move on to practice problem number 19. That is 12x squared plus 13x plus 3. 12x squared plus 13x plus 3. Okay, so again, there are multiple ways of solving it, but let us follow the simple one, that is, the middle term splitting. So in the middle term splitting, here your a is nothing but 12, because ax squared plus bx plus c. B is the coefficient of x, that is nothing but 13, and c is the coefficient of the term which doesn't have any variable, so that is nothing but 3. So a is 12, b is equal to 13, and c equals to 3. Then obviously we split the middle term b into two things like m plus n, such that m plus n equals to b. So that is nothing but m plus n will be equal to 13, and mn equals to AC, or your Mn is nothing but A here is 12 into C here is 3, that is nothing but 36. So A plus B is 13 and A into B is 36. So let us find out the value of A minus B. So your M minus N will be nothing but a plus b whole square, that is 13 square minus 4 into 36, right? So 13 square is nothing but 169, okay? And 4 into 36 is nothing but minus sign. 4 6 is 24, 4 2 4 3 is 12, and 2 is 14, minus 144, right? That is nothing but root over of 25, so that is nothing but 5. Okay, so we got m plus n equals to 13 and m minus n equals to 5. Now we can use it to find out the values of m and n. So let's find out. So we know m plus n equals to 13, m minus n equals to 5. Okay, m plus n is 13, m minus n equals to 5. So obviously, by adding both these equations, minus n plus n will cancel out. So 2m is nothing but 13 plus 5 equals to 18, or m equals to 9, right? Similarly, let's find out the value of n. So here we'll subtract both the equations. M plus n equal to 13 and m minus n equals to 5. If I'm subtracting these equations, and coefficients would be changed. So this will be minus m, this will be plus n, this will be minus 5. Plus m minus n cancels out. So here I'm getting 2n equals to 13 minus 5 is 8, or n is nothing but 8 by 2 is 4. Okay, so here we are getting m equal to 9 and n equals to 4. Now let us replace it in the expression. So now, putting the value of m and n in the expression, this can be rewritten as 12x squared plus 9x plus 4x plus 3. And if you see, obviously 9x plus 4x is 13x. So nothing is changed. So this is a proof that we are not making any manipulations while we are solving the problem. We are only expressing it in the right way so that we can factorize it, right? So that is nothing but. So I'll just do a bit of reshuffling. I'll take 4x here and I'll take 9x here. So I'll rewrite it as 12x squared plus 4x plus 9x plus 3. And you can write it as because addition is associative by nature. Okay, so that is nothing but now your it's a four terms. So I'll just group them by pairs like this, right? So between the first two terms, the common factor is 4x. So if I take 4x as the common term, what remains back is here it would be 3 into x, right? Plus 1. And between the next two terms, if I take 3 as common factor, then what I get back would be 3x plus 1. So obviously now 3x plus 1 is the common factor across both the terms. So if I take 3x plus 1 as the common factor, from here I'll get 4x, right? And from here it will be plus 3. And this is your answer. Again, this expression which was expressed as something plus something plus something or three terms, t1 plus t2 plus t3, we have expressed it as multiplication of two expression, or there is nothing but factor of two expressions, right? So which means we have factorized it, and the highest power of x in each of these factors is 1. So obviously this is the fully factorized form of the given expression. Okay, note it down, and then we'll go to the next practice problem. Okay, now let's go ahead. So the next one is mn plus 3p plus np plus 3m. Okay, so here if you see, so this is where we okay, so if you see here, if I replace this term to here and this term to here, I can rewrite it as mn plus np plus 3p plus 3m. Okay, so if I write it like this, then if you see, I will not get any effective common factor using which I can actually, solve it further. Okay, so rather what we would do is, rather than replacing the second and third term, and that is the reason why we have given the problem, right, in our curated sheet, that every time don't assume that you would just shuffle second and third term. If you see here I'll actually shuffle the last term as the second term. Okay, so I would rewrite it as mn plus 3m plus 3p plus np. Okay, and the reason is obviously addition is associative by nature. We can shuffle it. Okay, that's perfectly fine. And if you ask me how would I know this, obviously the answer would be by practice. There is no other way to know this, right? So now these two I'll take as the first pair, and these two terms I'll take as my second pair, right? So now between the first two terms, the common factor is m. So what I get back is m plus 3. Similarly, between term 3 and term 4, if I take p as common, then I'll get 3 plus n. Okay, so obviously I can write m into n plus 3 is nothing but p into n plus 3. Why? Because a plus b equals to b plus a. Addition is commutative by nature. A plus b equals to b plus a. That's why I've just reshuffled it. And remember, students, I am again insisting you keep the or have the habit of writing the reasons. Okay, it will help you a lot in life. Now, between these two terms, the common factor is n plus 3. So n plus 3 goes as the common factor. So what I get back is m from here, m plus p from here. So here you go with the answer. So initially it was expressed as sum of four terms, and finally we have expressed it as factor of two terms, right? And such that the highest power of variable m, n, and t is one only. Okay, so obviously this is the fully factorized form of what we wanted to solve. Okay, type it down and then we'll go to the next problem. Okay, so let's go to the next problem. Okay, that is 15 x squared plus x minus 6. Okay, so if you see here, we will not be able to take any common factor, nor will be able to derive it into any identity easily. Okay, so what we will do, we will directly use the middle term splitting, which means this is ax squared plus bx plus c format. So obviously a is nothing but 15, b is nothing but coefficient of x, that is 1, and c is nothing but coefficient of minus 6, that is minus 6. Sorry, I mean the term itself, x squared plus bx plus c, right? So now we know that we want to express the middle term into as summation of or into two terms as m and n, such that m plus n equals to b. So m plus n is nothing but b is 1 here, and mn is nothing but AC, or your mn will be A here is 15, C here is minus 6, that is nothing but minus 90. Okay, so m plus n is 1, mn is minus 90. So what will be the value of m minus n? So m minus n is nothing but m plus n 1 square minus 4mn, because a plus b whole square minus 4ab is a minus b. Okay, that is 4 into minus 90. Okay, so that is minus of minus will be plus. This is 1 plus 360 root over, or that is nothing but 361 root over, and obviously this is nothing but 19. Okay, so m plus n is 1, m minus n is 19. Now we need to find out the values of m and n. So obviously, let's find out the value of m and n. So m plus n equals to plus 1, m minus n equal to plus 19. Okay, so if I add both these equations, so my plus n minus n will cancel out, and what remains is 2m equals to 1 plus 19 is 20, or m equals to 10. Similarly, if we subtract both the equations, m plus n equals to plus 1, m minus n equals to plus 19. So if I subtract, then the coefficients will be changed, right? So plus m minus m cancels out, n plus n, 2n equals to 1 minus 19, that is minus 18, or n equals to minus 9. Okay, so m is plus 10, n is minus 9. Now we will rewrite the equation using m and n. Okay, so if we rewrite, or if we put the value of m1 n here, so we know m plus n is nothing but b. So we can write 15x squared. So this expression can be written as this equals to 15x squared plus 10 plus minus 9 x minus 6. So if you see here, 10 plus minus 9 is nothing but 10 minus 9, that is 1. 1 into x is x. So nothing is changed. So that is nothing but 15x squared plus 10x minus 9x minus 6. Now let's see what we can get as the common factor, and which ones it would make more sense to group them together. Okay, so if I take the first two, yeah, I think this would make sense. So group these two and group these two together. Okay, so between these two, I can write 15x squared plus 10x bracket minus minus. If I'm taking minus, then it will be plus 9x, right? Plus 9x plus 6. Okay. Now, between these two terms, let's see what would be the common factor. So the common factor here would be 5x. So if I take 5x as the common factor, so what I get back here is nothing but 3x. 15x squared by 5x, 1x cancels out, 15 by 5 is 3. So this is 3x plus 10x by 5x is nothing but 2. Okay, minus. Here between these two terms, I can take 3 as common, and what I get back is 3x plus 2, right? And between this term and this term, obviously 3x plus 2 is the common factor. Now I need a bit of real estate, so I will erase some part of it. Okay, so after this, we are just directly coming here, right? That between these two terms, the common factor is 3x plus 2. So if I take 3x plus 2 as the common factor, from term 1, what remains back is 5x, and from term 2, what remains back is minus 3. So this is your answer. Now, something that was expressed as T1 plus T2 plus T3 now is now expressed as F1 into F2, so the factors, right? And obviously, the highest power of the variable in each of the factor is 1 only. So obviously, this is fully factorized. You can type it down, and then we'll go to the last problem of our today's practice session. Okay, so type it down, and we'll go there. So let's go to our last practice problems of this session. Okay, that is minus 9x squared plus 6x minus 1. Minus 9x squared plus 6x minus 1. So again, there could be multiple ways of solving it. You want to solve it as a middle term split, yes, you can go ahead and solve. But what I would personally prefer is, I always say that my first intent is to take something common and then put it like identity. So if you see here, this term, so in all our identity, we have something as square, right? So if you see, there are two terms which could be made square here, 9x squared and 1. But the bad part is the coefficient of both of them is negative, right? But in all my identities, be it a square minus b square, or a square plus 2ab plus b square, or a square minus 2ab plus b square, the coefficients of all the terms with power 2 or the square terms coefficient is always positive. So what I'll do, my intent is to make the coefficient of the square terms as positive. So what I'll do, I'll take minus 1 as the common factor across all of them. So what I get is 9x squared minus 6x plus 1. And obviously we know taking common factor is nothing but we are dividing that much, from all the terms. So now if you see, now it can be pretty easily expressed as an identity. So this one can be written as square of 3x. The last term can be written as square of 1. And if you see, the middle term can be written as 2 into 3x into 1. So a squared minus 2ab plus b square format. Right? So minus 1 into this much. So I can say this is nothing but minus 1 into 3x minus 1 whole square. Right? Now, if you want to further simplify it, you can bring this minus 1 inside this, term. And obviously, if you get it inside, this will be 1 minus 3x whole square. And this is the perfect answer. If you write this also, this is correct. And if you solve up here also, this is absolutely right. Because in mathematics, we know there's an importance of solving or simplifying, right? So with this, we come to end of our this curated practice problem set. So thank you, students, and watch out for more videos in the same space. Catch you soon. Bye bye. Have a good time.